Figure 4 shows a sketch of a Ferris wheel. The height above the ground, h meters, of a passenger on the Ferris wheel, t seconds after the wheel starts turning, is modelled by the equation given here. H is equal to the modulus of a sine bt plus alpha, where the angle is in degrees, where a, b and alpha are constants. Figure 5 shows a sketch of the graph h against t for one revolution of the wheel. Important to note that this must be at 180 degrees, where it gets back to there. So, given that the maximum height of the passenger above the ground is 50 meters, the passenger is 1 meter above the ground when the wheel starts turning, and the wheel takes 720 seconds to complete one revolution. We want to find a complete equation for the model. In other words, we want to find the values of a, b, and alpha. So if the maximum height is 50, so that's the maximum on the curve up here, that must mean that a is equal to 50. We know the amplitude of a standard sine is 1, so a has to be 50. In the answers, they do see plus or minus 50, which is true because you're sticking it inside a modulus. I don't know how important that plus or minus is, since you're putting it inside a modulus anyway. Now, h is equal to 1 when t is equal to 0. So at the moment, we have h is equal to, let's ignore the modulus because it's going to be positive in this first bit anyway. So that is going to be 50 sine bt plus alpha. When we put these values in, we get 1 is equal to 50 sine alpha. Therefore, sine alpha is equal to 1 over 50. And alpha is the inverse sine of 1 over 50. And that is 1.15 when we're in degrees. So we just need the value of b, and that's going to be to do with the value 180 that we used here, because this is one complete oscillation just there. So one complete oscillation means the period is 720. And so if we look in here, BT, that means that B times 720 must be equal to 180. That's when it first gets back to 0. And therefore B is 180 divided by 720, which is 1/4. So our complete equation is going to be h is equal to, I suppose we could say plus or minus 50, it doesn't really make a difference there, sine, and we are going to have 1/4 or 0.25 t plus 1.15. Don't forget to close the modulus, and that is the equation. Now the last part of the question says explain why an equation of this, where d is a positive constant, would be a more appropriate model. Well, what does this d do? It is going to be a vertical translation of the graph. It's going to move it upwards. And the reason that that is sensible is because the original model would have this car scraping along the ground as it goes around. So clearly you have to raise it a bit above the ground so that doesn't happen.